Man, this automated machine learning is so cool. I didn't code anything. I just provided the data, and AutoML in Azure Machine Learning is doing all hyperparameter tuning, visualization steps, everything all automated to train multiple models for me and give me the best model. Yes, I know. Actually, I'm using AutoML right now in Databricks. But wait, Databricks? Yes, even Databricks by itself has AutoML capability. Oh, cool. Then what is the difference between Azure ML AutoML and Databricks AutoML? Good point. Actually, let's do a quick test right now. So we can use the same data set to train models using AutoML in Azure Machine Learning and the same thing using AutoML in Databricks. And then we can check the differences and capabilities and compare to each other. I love it. You should join us. Exactly. And let's go. Hello everyone, this is FG and welcome back. In this video, we are going to compare the differences of capabilities between Azure ML Automated ML versus Databricks AutoML. So let's make sure you're tuning in and let's check it out. Here is my Azure Machine Learning workspace. That's the place. Of course, we're gonna leverage AutoML in this Azure Machine Learning workspace that I have. And of course, we are going back all the way to my Databricks as well in Machine Learning workspace to actually execute AutoML here as well. And then do a quick comparison of the capabilities here and how they look like when using their UI. So, of course, for setting up any AutoML run, in Azure Machine Learning or Databricks, we certainly need to have data. So I have already downloaded a training data set as an example from Kaggle. Regardless of the data, anything that would be a tabular data, for example, that we're going to use for a specific AutoML experiment, you can certainly do. Even in Azure ML, we can use now with non-tabular data, let's say AutoML for images, AutoML for NLP. I have already recorded those videos and I'll add them to the top right of this video if you want to check them out. But here we're going to deal with tabular data, and in order to run AutoML in Azure Machine Learning, you certainly need to create the data and also the compute. So coming to the compute, let's first create the compute in both Databricks and Azure ML, and then we create the data set and then we execute AutoML. So for the compute section, we need to have multiple machine learning models getting trained in parallel using AutoML. As you know, AutoML certainly create multiple runs for me to give me the best model. So we are going to create a cluster. You can see I have already created a cluster, but just very quickly showing you how I did. You just click on new, you check the location, CPU, the type of the machine. Because we want to do a similar benchmark between AutoML in Azure ML and Databricks, I have chosen the same machine, virtual machine type in Azure ML cluster and Databricks. So a standard DS3v2. This is the machine type with 4 cores and 14 GB of RAM for general purpose. If I go back to Databricks, I'm gonna create the same machine here or the same cluster. So I should go to compute. You can see I have already created a cluster called AutoML. Actually, let me show you how I did. You just click on create new. I called it AutoML. Let's keep this runtime as is. Oh, by the way, you need to create a machine learning runtime because we want to leverage AutoML. And of course, for the machine type or worker type, we are choosing the same tier, DS3v2. DS3v2. Minimum worker nodes 2, maximum worker 8. That means maximum 8 machines gonna be connected together to create this cluster to run AutoML in parallel for you. Here I chose the same thing and I put the mean in 2 and the max as 8, and that's it. I clicked on create. So I have it already. I'm not going to create again. I have it here. And same thing to this one. I'm not going to create it because I have already created here. And you can see it's an ML runtime with minimum 2, maximum 8 working nodes with the same machines. All right, that's about compute. Now, coming back to my data. Here's the place that we need to register a data set before running AutoML in Azure Machine Learning. So I click on data. I have already created my data set, but just show you how I did. I clicked on create. For this demo, I downloaded the data from Kaggle, so it's in my PC. So I want to upload it to Azure ML. This is the way I'm gonna use. I click on from local file. I named it as training. It's a tabular data. It says it already exists because I created it. So let's add a number, any description, clicking on next, clicking on browse files. This is my training data that I downloaded. Clicking on next. It is parsing the data. Let's wait for a bit. There you go. It's an overview of my data. I click on next. Actually, you can do some specific changes here, but I think I'm good with the file format, delimiter, comma, UTF encoding, column headers, which I want to have them. You can see my features here, regardless of again the data, just as an example. And skip rows done. Before I move forward, let's see how this part looks like in Databricks. So again, we created the same compute in Databricks, so now we're gonna do exactly the same thing in Databricks, step by step, comparing the steps. So I need to have the data. You go through the data section. You can see again, I created the same data here, but how I did, you click on create table. Again here, I am uploading the data from my machine, so I need to click on train. You can see it is uploading my CSV, exactly similar to what we did in Azure ML. Now we are doing in Databricks, and let's see what it shows after we upload and compare to Azure ML. Alright, so now it is telling me that you can now create a data set or table out of this CSV file through code. I can give you the notebook or through the UI. Because we are working with UI in Azure ML, let's also choose UI as the way to creating this table as well, which here you can code as well in the notebook, but here we are both using the UI. And of course, it's telling me for previewing this table, you need to have a cluster. I'm going to choose the same cluster we created. Preview. This is very similar to this preview that we see right now in Azure ML. So Databricks is trying to create the same thing for me. The first thing, you need to change the name. Let's name it as training, because that's the same name that we created in Azure ML and we gave it a number. You can have separate databases, create multiple databases in Databricks. I want to choose the default one. That's a CSV. The delimiter is comma. Very similar to what we are doing here. And then I want to have first row as a header. You can see now the headers are part of the data, which is not the case. So I click on first row as header. And now you see my first row is now the header, gender, customer type, age. So these are the features. And if I click on create table, it will create it for me. But I am not going to create because I have already created that. But let's go to Azure ML to see what steps are still left. So I click on next. The cool thing that Azure ML does that I didn't see in Azure Databricks first is it will telling me some automated type detection of my features. For example, here I can see the ID has been detected as integer, but the gender has been detected as a string. So I can even change them here, but I see it did a quite great job of detecting the type of my features. But what I saw in Databricks gave me the same capability. Also, I can see the type of my features, but interestingly, all of them were detected as string. I didn't change anything here, and I tried to have everything the same like Azure ML to make sure this is a difference or not. So I had to manually change some of them to integer. For example, these are the review of a service for a passenger within the flight. How do you like the food? 0 to 5, sort of a level for scoring that. How was their seat comfort in the airplane? So this is the manual steps that I did to make sure everything matched with Azure ML. I'm not going to do it again because I already did, and then I created the table. So here I'm happy with what Azure ML has been detected for me, but again, you can change if you want. And you can exclude features that you don't want to use them in AutoML, sorry, for registering that here in dataset. I want to include them all, so I click on next, and that's it. If I click on profile list dataset after creation, after registration of this dataset, it will create a kind of overview of statistical characteristics of my data. What are the distribution of the features? What are the mean, max, median? And I'll show you actually. So I'm not going to create and finish it because I already did. You can see it's here, training. So I'm going to cancel, assuming that this is the data set that we created. Also here, if I click on create, my training 01 going to be created. Again, I'm not going to do that because I did and created here as well. So coming back to the data, you can see the training is already created for me. And if I click on it, I can have a quick overview of these data set as well with some even sample data. So if I click on training, here I can directly explore the data. If I click on explore, this is the profile that I told you about, that Azure ML can create a profile out of the data. You can see the distribution of each feature, some statistical information about, so on and so forth, which you don't necessarily see here at the beginning when you create a data and table, but I'll show you when you run the AutoML, it will automatically generate a notebook for you in Databricks that explain your data. But here, without having even AutoML there, I was able to have the explainability in UI without necessarily showing me the code of these. Just in the UI I was able to see, which I don't have it yet in Databricks, but we'll see after AutoML run in Databricks how we can have them. So now that was about the data. So we created the data in both Azure Databricks, which is called training, and also I have it in Azure ML training dataset. This is the time to trigger AutoML in both platforms. I click on AutoML. Let's start the Azure ML first. New automated ML. This is the dataset that I'm gonna train AutoML training. I think it will again quickly show me. Oh, it is asking me give me a experiment name. You can say this is a test. But I already created an experiment, so I can use that one. I call it, okay, I don't have it. Let's create a new one. It's AutoML test, let's say. The target column, that's the column that I'm going to predict, which is, let's say, the passenger's satisfaction after that specific flight. So we want to predict what's going to be the satisfaction of the passenger for upcoming flights. So I have the satisfaction, the compute cluster. Remember, we created a AutoML cluster with 2 to 8 nodes. I can choose it and I can click on next. But before moving forward, let's do the same in AutoML of Databricks and see the difference. So for creating AutoML in Databricks, you can actually go to home. You can see even AutoML here, or even in experiment, can see create AutoML experiment. Similar thing, it is asking me give me a cluster name. Remember, we created a very similar cluster in Databricks like Azure ML. I'm gonna click on it. We are doing classification for here, which is prediction of satisfaction of a passenger. They're satisfied or no, yes and no, binary. The data set, of course, that would be the training data we created. And the same thing, here we said this is the target column, we're gonna predict. Here it is asking me prediction target. The same thing, I wanna say satisfaction of the passenger is something I'm going to predict. Give it a name, the same thing. We created a name for experiment, AutoML test. We can maybe have the same name here. And before starting AutoML, I want to check some advanced configurations and compare to the configurations of Azure ML. So far almost the same and very similar. And this is, again, these are the data types that I changed manually while Azure ML had detected for me automatically. Okay, so let's move forward with Azure ML. I want to do classification. Here's the first main difference. For classification, I can even have deep learning to be checked by AutoML, whether deep learning maybe is a solution for this classification. But here, when I selected classification, these are the training frameworks that doesn't necessarily include deep learning. But here I had this choice in Azure ML. Let's check out some advanced configurations. What is the metric that you want to have your AutoML to choose it to evaluate the performance of your model based on that metric? Let's make it simple. If you're asking AutoML that, hey AutoML, give me the best model after all the models that you try, then AutoML is asking you, what is the definition of the best model for you? Based on what? Based on accuracy, based on precision, recall, so on and so forth. Here I want to say based on accuracy, give me the best model. So I'm Databricks. Here we have the same thing, give me the accuracy. Explain the best model. We will sort of have this, but right now is not a choice for me in Azure Databricks, but in Azure ML I'm choosing that. Here I can block some of the models that I don't want AutoML to try them. So if, let's say, for any reason I know that I don't want to try like GBM, I block it and select it here. That will also reduce the time that AutoML will need to finish the runs because you're testing less models. But here in Databricks, I didn't have this capability and choice. Actually, you can see in my configurations, in optional configurations, I don't have any blocking mechanism of choosing models. What else? Additional classification settings, positive class label. This is the positive class label that automated machine learning will use to calculate binary metrics. That's a good thing. It's optional. Actually, you don't need to specifically say anything here, but I don't have it here at all. Exit criterion. What is this one? You can say that after maximum 6 hours, I want to stop AutoML. That's a kind of saving efficiency and cost. You don't want to run AutoML for more than 6 hours. Or you say that if my threshold, which is now accuracy, is more than 90%, then stop AutoML because I don't want to have a model better than 90%. If you reach that at any time, stop it. That's the best model for me. Do we have it here? Not really. We just have the time, the same thing that we have in hours. Here we have in minutes. But the other thing that we have here is the number of trials. Here's the number of total models that, let's say, Azure AutoML in Databricks can try. Let's say it's gonna try 200 models and trials to give me the best model. Here instead I have the metric threshold. Concurrency, the maximum, it's 8 because my cluster has 8 nodes. So in parallel we can have 8 concurrent training for different models, which here would be the same because we are creating 8 node cluster in Databricks as well. Here we can specify the column that you will be used for splitting your data for training, splitting, so on and so forth in Databricks, but in Azure ML it's a little bit different. So the way, okay, let me close this. And before also showing how this part looks like in Azure ML, let me also finish that part. If I click on View Featurization Settings, here is another cool thing you can do in Azure ML. You can also say that I want to change any of these feature types. Let's say now you decided to have the flight distance as numeric if it's not already numeric. Or you can make it auto, so Azure ML AutoML automatically detect the type of these features for you. Do we have this in Databricks? Well, in Databricks the data type is already selected based on what you selected when you were creating the data. So here I cannot change them anymore, or I don't have this auto option in feature type. These are actually fixed values, I cannot change them. But if there's any missed value in any features in any columns of these feature table, or let's say in flight distance feature I have some misvalues, you're saying to AutoML of Databricks that, hey, fill those misvalues with the mean of flight distance, with median, with the most frequent one, with the constant value, or make it automated. So Databricks AutoML will select what would be the best strategy for filling the missed values for flight distance. Do we have this in Azure ML? Yes. So almost the same thing. You can make it auto or fill with median, most frequent, mean, and with the constant value. So input width is very similar to input width we have here, but the data type here is fixed, but here you can change it. So that's it. I don't want to change anything but just showing the differences. If I click on next in Azure ML, here we had a question of what's going to be the column for splitting the data to train and test. We can choose, but here instead it is telling me that give me the validation type. You want to do tenfold cross validation, let's say here, or you want to split your train and validation based on the percentage. I don't see any question of percentage here in AutoML of Databricks, that how much of data I want to specify for validation and testing versus training. And also I don't have any choice in Databricks for validation type. Let's say I want to do tenfold cross validation, or no, I want to do Monte Carlo cross validation. Here I don't have those choices at all. And then let's say for validation I want to do tenfold cross validation, but for testing, of course, in machine learning we have training, validation, testing. This is for validation. Now for testing, I can also specify another data set which my model has never seen to test, and I can provide a separate test data. I can create my data. Actually, I have it in my machine, so I can upload my test data. 01, clicking on next. You see that from the same Kaggle I have the test. I can download and create. I don't want to do it because I already did it, and I can choose just my test data. There you go. So I'm saying that validate the model with tenfold cross validation, and there's a separate data I registered before as test my model after that. If I click on finish, done. It will start AutoML. Now coming back to Databricks. Again, I don't have the option of providing a separate test data set here by myself unless I split this with the given data that I have. And that's it. This is the intermediate data storage that can be MLflow or Databricks file system. If I start AutoML and if I click finish in Azure ML, both AutoML is going to be started. To save the time, I already did the same steps that I explained you, so let's go through the results. If I go to experiment, you'll see AutoML tests. I just did it before recording. Let's see the results. Same thing in Azure ML. I'm gonna cancel it because I ran it, and if I go to AutoML, here's the latest run, and let's check out the results. So first of all, it's giving me in Azure ML a nice overview of who created this AutoML and what time exactly, what was the total duration. So in 17 minutes, AutoML in Azure ML ran multiple models for me, different hyperparameters to give me the best model. Here is a quick summary of the best model, what data being used. We had a data called training used for in Azure ML, AutoML, and some other information as you can see when I'm sharing my screen. But when I go to AutoML experiment of Databricks, I do have sort of similar information, but not necessarily as detailed as here. For example, I have the total minutes, 17 minutes in Azure ML. So I wanted to see how long did it took exactly in Databricks AutoML. I see that it is telling me the duration of each model that AutoML did in Databricks, but I don't see what was the total time of all these runs, if it's more than 17 minutes or not. But approximately they finished around the same time when I was actually testing. But again, it would be more nice if I can see a similar thing with more details like this one here, and even in a very quick way, if I was being able to see the best model and the values as I see here, would be nicer. So just again, I'm switching back between these two because these are the main differences for the overview of your experiment. Now, if I go to next tab, data guardrails, you see that AutoML of Azure ML did some testing for it, checks for me, like guardrails. For example, do I have class imbalance in my data? No, I passed that test. Well, it splitted the data for validation, which we specified. Do I have many missing feature values? So it done because it detected, if it was detected, it imputed for me. Do I have cardinality between features? Which seems like I didn't have because I passed it. So does Databricks do similar thing? Let's check. In Databricks, I saw that there's a tab called warning. I checked that and some similar thing that he's doing, trying to have some guardrails for me. Let's say here, it's saying me that, hey, I detected some categorical features and I encoded them, which is needed for sure for machine learning. And it says your data was a bit big, so data exploration was a subset of data, and some other warnings here. But it didn't tell me some other information like this one. Maybe they all passed. If, for example, this one was an issue, Databricks might tell me as a warning. But it doesn't show me as a checked guardrails. If there's an issue, it will tell me with the severity. So that's the second thing. The third tab is the models. Let's see how many models so Azure ML, AutoML created for me. So the base size is 100. So you can see that I have maximum 15 models, and this is the best model for me. The first one, which is a voting ensemble. Coming back to Databricks, let's see how many models this one created for me. Let me check, load more. Okay, do we have any information here to show? It is actually more than 100, because when I downloaded all these results as a CSV file, and if I open it, you see that it is telling me showing 200 matching ones. Remember, we selected 200 as the maximum number of trials. So that's why it tried 200 models with different configurations for me. So definitely Databricks AutoML tried more. You can also scale in Azure ML to let it try to have different models with having less constrained exit criterion. But interesting thing here is the best model. So let's check out the validation scores first. If I go to the validation, let me click on metrics. It's a bit slow. Okay, let me minimize them. So here actually I have ranked or sorted my results based on from the highest accuracy score. So the first one, which has 96% accuracy, is actually a light GBM model, right? But here in Azure ML, very actually similar accuracy, actually almost the same. But this is actually for validation. We should check the testing, because now here we are checking the test results. So if I click on the best model, let's go to the test results to make sure they have the same thing. So Azure Databricks in test result has a very slight better results than Azure ML, but because on backend we didn't have the flexibility of choosing the percentage for validation and testing, that might be a reason that there's a slight change. It's not just because of the model performance, but here in Azure ML I had the chance to provide this percentage and the way that I want to do validation, and of course the performance. Alright, so interestingly, when I checked majority of these machine learning models, I just saw light GBM, XGBoost, random forest, so on and so forth. But Azure ML can also stack multiple models or through, let's say, ensemble voting. What is voting ensemble? That's actually a combination of multiple machine learning models that each of them do a specific prediction, and then we vote for what was the majority of the predictions of those models to select that as the finalized prediction. But I didn't see that type of stacking mechanism and ensembling in Databricks. It might not chose that, or it's not actually having any stacking mechanism or assembling mechanism in the models. That's another difference I specified. And when you click on hyperparameters, you can see different configurations that has been chosen for this model, different hyperparameters that Azure ML decided to choose, the accuracy, and of course you can see nice explanation. But before going that, very similar thing that you see here, some metrics, some the parameters that has been chosen for this model. But for each single model, if you click on notebook, it will give you the code that has been generated to be used for training that specific model. So if you want to know how this model has been created, here's the code, here's my data, and interestingly, here is the train validation test split. So it is telling me that 60% was used for training, 20% validation, 20% testing. So it is hard-coded somehow here for me, and that's why maybe it didn't ask me these specific questions when I was running AutoML of Databricks. But in Azure ML, I was able to specify all of this percentage and also specify the validation type. Cross-validation, Monte Carlo, train validation split, which I didn't have the choice. So that's one of the main differences that I saw. All right, so coming back to Databricks, that was the code that I showed for the best model. It is telling me that it's scikit-learn, and if you click on it, you can even see more information about it. You can see it is telling you that this is the way you can do prediction with this model using pandas or Spark data frame. You can register it to create the real-time even endpoint for this model. You can see it is sort of like an ML flow experiment. I have all different information that I can reproduce this experiment. What is the model? What is the packages that you need to install for recreating or training this model or inferencing this model? Here are some metrics that automatically has been logged for the best model for me, which I have the very similar thing in Azure ML. I can go to the best model, can go to the metrics tab, and there you go. You can have a very similar information with even more charts, choices. You can select one as a table or charts for any specific metric you want. It's very similar thing that I have them all here being captured for me. But here's mostly images. Let me see if I have also, yes, I have also the values here as number. Very similar and equal to what we have in Azure ML. Now coming back to Databricks, if you remember, when I registered a data set in Azure ML, it profiled that for me. So it showed me the statistical information, distribution of the features. We didn't have that at the beginning when we created a data table in Azure Databricks. But after running and finishing this AutoML, you see that there's a tab called View Data Exploration Notebook. Now I have that specific exploration that we saw in Azure ML in Databricks with the codes that has been used for generating that. You can see now the overview of the data, specific information, very similar to what Azure ML profile for dataset give to me, distribution, specific data, if you have missing values, so on and so forth. So that's another difference that I can highlight. So that was being created automatically when I finish AutoML. View the notebook for the best model. The best model is here. We just saw already in the notebook, but if I click on it, it will show me the same thing, that hey, this is the best model and this is the code that has been used to generate the best model for you. So here in Azure Databricks AutoML, I clicked on the best model, which is a light GBM, and we went through metrics. Here are some specific parameters chosen for this experiment, and the run, which is like GBM for creating. You can have a specific description, you can have tags. Here are the artifacts, which is the model, the YAML file, the environment used for training this model, and some image-based metrics that has been captured. That's it. But if I go to Azure ML, there are some more specific things that I can have. So if I click on output and logs, very similar to what Databricks gave to me, the model, the Conda environment, like the pip packages. So I have them the same here in Databricks as well, right? Let me show you again. We have it here, artifacts. Now you have it in Output and Logs tab. But there's an interesting tab called Explanation, which is basically a dashboard explaining for me that how your model is predicting the final outcomes, right? For example, what are the top 4 important features for this best model of AutoML to give you the prediction? For example, the Wi-Fi service of that airplane was the most important feature to provide satisfaction for the passenger. Or the online onboarding experience, type of travel, the class of travel. You can even increase it to more top, let's say 10 features, right? Not only aggregated, this is general for the model. For each individual prediction, if I click on individual feature importance, these are my each individual sample or passenger here. If I click on any, let's say a random sample, you can see the feature importance for that just a specific prediction of the passenger, not the aggregated one which we saw, which is pretty cool, right? You can even explore the data further, the distribution of the data. It's totally interactive. You can change, let's say, the values here. Let's say I want to check the age versus the satisfaction of the passenger, which is the true Y. We can see, for example, what is the distribution based on this box plot of different ages that were satisfied or not satisfied. And even the model performance, let's see, I want to see the probability of someone being not satisfied, a passenger not being satisfied based on, let's say, gender. Oh, sorry, I selected age actually. So within different age ranges, you can see the probability of not being satisfied is different, which is pretty interesting. But in Databricks, I didn't see an interactive UI of providing explainability for me, like feature importance, individual feature importance. So mainly all these 4 tabs which come from explanation of the best model, I don't see any explanation tab of the best model when I am in Databricks, which is another difference here. So now the last part here would be, now I'm happy with this best model in Databricks. How can I deploy it, right? So for making any predictions, for offline or batch prediction, you can just technically use this code snippet for doing prediction on a Spark data frame or Pandas, right? But in order to have a real-time deployment, you need to register a model, and then you will create a REST endpoint, which is basically a cluster of Databricks running for you with 24/7 listening for any call to do a prediction real time. Then how does it work in Azure ML Databricks? So this is the model that you have. You just need to click on deploy to real time or web service. On backend, it can launch a Kubernetes for you or container instance. You don't have these choices in Databricks yet. You can do it, there's a workaround, but it is not like directly as Azure ML. You just click on Kubernetes and you will deploy over there, right? And then you just give it a name, and that's it. You click on deploy, it will give you an endpoint that this is your real-time model that has been deployed for you, which I'm going to quickly pass for now. And something that I forgot to mention, since Databricks also generate the notebook of the best model for you, for example here, also in Azure ML, you can have the generated code of the best model that has been used for creating this model for you. And these differences and comparison that we went through is, as of now, the time that I'm recording and posting this video, both AutoML in Databricks and AutoML in Azure ML are evolving, and you might see more and more features coming in. For giving you an example, now as of now I'm recording, you can even use AutoML in Azure ML with NLP, AutoML with images or computer vision, which they are not supported yet in Databricks. But again, you might see in future, later on when you watch this video, there might be more capabilities have been added to these services. Both of them are fantastic services. Both platforms are providing great capabilities in their AutoML, and there is no significant change that I can or difference that I can highlight here, but it was just like a nice story of going through one by one each to see which one you think is more reasonable for your choice, but still both of them should be applicable for any specific experiment that you want to use AutoML whether in Databricks or Azure ML. And that's it. We hope that you liked the video and now you see how helpful AutoML is. Until next week, see you later.